Hello, everybody. Today is our second lecture of the MIT App Inventor series, and today I'm going to be developing an app about integrating classical ML models in the MIT App Inventor interface by prediction of diabetes. I hope you enjoy. So, for any classical ML project, we're going to need a certain database on which our model can learn. So for that, we're going to go to kaggle.com, click datasets. And for this project, since we're working on a diabetes project prediction, we're going to search PIMA Indians diabetes database. And we're going to click datasets over here. And the first one by UCI machine learning, we're going to use this. This is basically a database composed of different factors that influence diabetes and then the outcome, or this is the labels. This is the label and this is the features. So what we're going to do is download this data set. And now that we have our data set, we're going to head over to collab.research.google.com. So this is, if we don't know what Colab is, that's okay. It's basically a place where I can write code, Python code, very easily. So I'm gonna rename this to diabetes prediction. So yeah. So now that you've downloaded your database, what you can do is first let this connect, and then we can upload this database into our Colab runtime. So now that what this does is gives us access to the database, and as you can see, we can see the data over here. So first, what we're going to do is upload our start our import. Sorry. So what we're gonna do is import first NumPy as NP, and this is used for arrays and data manipulation. It's very helpful. The next thing is for import pandas as PD, and what this will do is basically help us um, with data manipulation and reading these CSV files. After that, we have to um, have some tools to create our models. So first of all, we're gonna have from skykit-learn. So from skykit-learn, sklearn.model selection, import train test split. So this part right over here. And then now another thing we need is the model itself. So from sklearn dot no, just from sklearn import svm. So this svm is a certain model that it's a traditional ML classification model that we can use to predict diabetes with great efficiency. And the last thing we're going to need is an accuracy score. So what we're going to do is sklearn, yeah, so sklearn.metrics import accuracy score. So all stuff, and this is basically to measure the efficiency of our model to make sure that it's predicting everything okay. So we're going to click shift and enter, and this is our first set of code that we're going to import for the imports. Now I'm just going to annotate this a bit. So now we're going to have our data analysis. So we're just going to look over this diabetes.csv file and try to comb over the features and see what's wrong, if there are any abnormalities with it. So what we're going to do is first diabetes database is equal to pd.read csv, and what you can do is go to this the files and click the three dots to the right of diabetes, click copy path and copy it over here and now we can check whether this worked properly by diabetes.database.head. And what this will do is basically display the first 5 records of our thing, and as you can see, it's the same as over here. So we have successfully loaded our database. Now what we have to do, and we'll also check the shape of this to see how many like how many records there are. If there's so we have 768 we have 768 records and 9 features. So let's just check. Um, Yes, let's just describe this. So this is like statistical analysis of everything, like how much um the median, the mode, the mean of everything, the of each, the median, the mode, the mean of all these certain columns. So it can give us the amount of everything. And now that we have an idea of what it really is, we can check the. So now what we need to do is now that we have an idea of what our database looks like, we also need to check the frequency of each outcome. So what I mean by this, so let's just make this a nice little visualization. So what I'm going to do first is import our visualization libraries. So import matplotlib.pyplot as PLT, and this should come as a recommendation, and we should click Control Enter. And now what this will help us to do is basically like help us visualize how our data looks in terms of data analysis. So first what we have to do is count the number of zeros and the number of ones. So diabetes, database, and outcome is the feature that we're trying to predict. So we're going to check on that, value counts. And then what we're going to do is kind of make a figure out of that. So first what I'm going to do is establish the figure and the size of it. I'm going to make it 6 by 8. First we have to write fixed size over here is equal to around 8 by 6. And then, so we have that. And so now what we need to do is make a bar graph. So plt.bar label counts.index comma label counts.values. And this should also, if you're using Colab as I am, you should really it should work as a kind of recommendation system. So, and we'll just let that. So as you can see over here, the amount of zeros is much the amount of zeros is much more. Then I'll just also show you the numbers so that easy to see. Yeah, the amount of zeros over here is much more compared to the amount of ones. So this is a problem in our data set, and what we need to do is fix it by removing the number of zeros, so approximately 252 zeros, so that our 242, sorry, so that the number of zeros and ones in our data set will become equal, and we can then write code on it. Otherwise, what will happen now is that the model will be biased to choose zero as an outcome most of the time because it has a higher frequency, and that's basically what happens. So we need to fix that by um, so we need to undersample. So this is known as an undersample. So what we need to do is so we need to first extract um, the amount that of zeros, so the records that have zeros in them. So this is basically what it is. Diabetes database where the outcome is zero. So what this means is we comb through our entire database, and wherever the outcome is zero, it'll add it to our df class 0 database, and wherever it's 1, it's going to add it to the class 1 data frame. So now after that, we are now going to try and so now what we have to do is undersample. So first let's check. So we have to sample. So what we're going to do is df and 0, the class 0 is the one that we have to sample. So we have to df class 0 is equal to 0, df class 0 dot sample. And then so this is basically going to take a number of, it's going to take, so I'm just going to write the code first, and then now what this is going to do is sample out of this data frame that we established. It's going to extract a number of rows out of such that the length of the data set is df class 1, or 268 to be exact. So after that, now we just have to merge the two databases that we have using this um, code right here, which is concatenating or merging the two databases of df class 0 and df class 1. So now so now what should happen is that we should have an equal number of zeros and ones in our data set. So if we check now, I'll just check, and sorry, I put the wrong database, the wrong number, the wrong name. And now we should have exactly, we should have an equal number of counts for both. So now that we have they're like a somewhat decent data set to work with no bias or anything, we can now try to start training. So we're going to extract our features by extracting we're going to keep all the data, the features, all of these over here, except the outcome, because that is the one we're going to predict. So we're going to drop the outcome, and then you have to write columns is equal to outcome, and we have to ensure the axis is equal to 1, which means that we're looking for the columns and not the rows. If we put nothing here, if I removed it, I would get an error, as you can see. Oh, never mind. That also works. So now that we have the x value, now we have to introduce the y, which is the variable that we have to predict. So diabetes database dot. So we're going to extract only the outcome from this. And now if we try and print our x and y, x is, as you can see, it does not contain the outcome, and y only, lowercase y only contains the outcomes. So now what we're going to do is, in the start, we imported this train test split, which basically allows us to randomly, out of this database that we've created, we can divide it into two separate uh, sets of data, the train set and the test set. Now, the train set is used for the model to optimally try and use this data in order to learn all the features and accurately predict. So that would include like around 60 to 70%, or 70 to 80, either way, around 75% of this data set and 75% of this data set, and they are mapped to each other. And then 25% of this database would be used to evaluate the accuracy of this model. That set is known as the test set, and we're going to basically now divide it. So x train, x test, y train, y test is equal to train test split of x comma y, and then we're going to have the test size, which is basically the proportion of the test size. We're going to have that 0.2%. And in order to make it a bit random, we're going to set our random state to 2. Yeah. And so now we have our x train and x test. And if we print the shapes of this, if we print the shapes of all of them, so the initial shape, x train shape, which is basically the dimensions of this, if we have that, and y, and it's essentially the same thing, then we basically see that it's divided in equal proportions. There's 536 rows initially, and they're converted to 428 and 108 rows respectively. So now what we're going to do is define our ML model. So now that we've done our data analysis and we have our separate train and test sets, what we're going to do is try and generate the model. So we're going to train the model. So first we're going to define our model as, over here we imported SVM. So we're going to use SVM as, so within SVM, we're going to use the SVC model, which is a certain type of model and an inefficient model. And we're going to use a kernel as linear. So now what this means is, So what this means is that it'll calculate the dot product between two data points, which it means that it only considers linear relationships without the between the data without any complex transformations. And since our data is already linearly separable, meaning it can be divided by a somewhat straight line, the linear kernel would be efficient in this case, and that's why we're using it. So next, we're going to try and train the data. So model, we're going to train it on our X train and Y train. And so we wait for a few minutes. So as you can see, our model has been trained now, and it has been fitted. Now that we have trained our model, we need to learn how to evaluate the model and check how effective it was given our data set. So the first thing we need to do is predict the values of y train given x train using this function right here. And then what we need to do is find the training data accuracy between the x train prediction and y train. So what this is going to do is basically compare each of the values between y train and x train prediction to make sure that and see how many of them are the same, and around 75% are the same. So and we do the same thing for test. Remember, the test data set is the one that is not that the model has not looked at, and it's the other 20% of the data, and it's around 82%. So that's a good accuracy for test, and we can move on with that. So now we'll learn how to basically ensure that how to make use our model to predict on new data points. So such as say the user enters these values respectively, then we need to make sure the model can predict it right. So for testing, I just use the first row of our diabetes database, and I put them in the form of an array and predicted it, and we get the prediction as 1. Now 1 is the right outcome, so we can make so this gives us some confidence that the model is working. So next we need to learn how next is the saving of the model as a pickle file, and this will be useful when we basically use the API, which I will show you in just a little bit. So now that we've finished our model generation with Pickle, we have to now integrate it with an API. So an API is basically a system that will allow us to use a web server to communicate and basically upload our ML models into MIT App Inventor so that we can predict the diabetes. So I've already written the code up for this. Feel free to copy it down to follow along. So these are all the dependencies we have in order to generate our model. So this is for running the middleware. This is for running the API itself. This is for the server that we will use to host on. So all of this is required. So please go ahead and download all of this. And then now we have to import these these modules into our code so that we can use them for future use. All of these. Then first we create our app, which is app is equal to fast API. Then we add the functionality to this app. So is that what this basically means is that we're adding a certain degree of functionality to communicate with the it's basically it's a security feature that would be implemented by web browsers that would restrict how resources on a server can be accessed from different origins. So the first line app.middleware, which would add the core SM middleware, would handle cores related requests, and it would run the middleware is the code that basically runs before each request and after each response. So allow origins is equal to origins, which this part it specifies the origins or the domains that are allowed to send requests to the server. And since we use star as origins, it can be since we use star as origins, we're basically allowing requests from all certain types of devices. Next, we have the allow credentials is equal to true, which allows cross-origin requests to include credentials like cookies and authorization headers. And I know it's not really required, but it's good practice to generate our APIs. And allow methods is equal to star, which allows specifies which HTTP methods like get, post are allowed for cross-origin requests. And setting this to star, it will allow all the methods. The next, allow headers is equal to star. It defines which headers can be included in requests from other origins. And by setting this to star, all the headers are allowed. So now that I've explained what this basically does, now we're going to get into what this is. So the model input is what we're going to be feeding into the model that we just generated. We're going to feed this model input with a base model class inherited inside this to basically define all the this is basically defining all the features, pregnancies, glucose, blood pressure. As you can see over here, it's just putting it into a class form so it's easier for the API to set the values later. Now we load our model and we create a route or a certain route out of here that would basically allow us to make our basically allow us to send requests to this. So what this does is allows us to create an endpoint that would, so when we send requests to this, it will run the following code. So first we need to convert our code into JSON. So this is a form that APIs generally like to use. It's a very easy form to use and it will be very efficient. And this is the only, I think other forms are supported, but JSON is the easiest to handle in terms of data. So we convert our JSON into a dictionary form, and once we have that, we will convert. So basically, this input paras is what we, as the user, will input into MIT App Inventor, which will then be fed to this API, and we will get our results back onto display. So that's what's happening over here. We're basically loading the input data into a dictionary. We are loading it all over here. We are setting our values. Then we're putting it into a list. We're converting it into an NP array, as that's the only form the model supports. Then we're checking if the database works. So now after you've done all this, congratulations. And now what we're going to do is go to um, a service called Ngrok that will help us host it will help us host our API to live to the internet basically as a web server so that we can basically use it for our MIT App Inventor. First, Google Ngrok, and the first thing that will come up is Ngrok API Gateway. So now after that, we want to log in. And so since I already have an account, you guys can sign up. And first, we have to use our auth token. So this is basically an authorization token that would be used as an API key that will allow us. And this service, it lets our service know that we are legitimate users that are trying to create something. So just feel free and try to make, so go to your settings and go to getting started your auth token as soon as you log in, and it will allow you to copy this. So now we will make our. So now what we have to do is ngrok auth token, and then we paste the thing that we have here. So we copy this here and we paste it, and there you go. And now we have the authorization token set. So now what we have to do is actually run it. So now what we're doing is running our web server that we just coded onto this this service using this code so far. So what Uvicorn does is a type of service that offloads the APIs onto Ngrok so that it can host it on a particular web server. So now it has started running. So before we get into testing this, I'd just like to make one corrections to our code previously. So before this was route, And I'd like you to change it to post and then click runtime, then restart session and run all. And that should fix some of the problems we had earlier. So now I'm going to show you how to test our API. So first, let's go to postman.com, which is a very nice site that we can use to efficiently test our APIs very quickly. So let's just click new request here. Then over here, as you can see, we have our a text box so we can put our code in. So go over to Colab and copy paste your public URL that Ngrok gave you, and then click post here /prediction, because that was the name of our thing, and then we of our route, and then we have to put in input data. This is again the first row of our thing. Then so let's check what it gives us, and we have the person is diabetic. So if we look over at our Colab, we can see that this was 1, which means the person is diabetic. So this means our API is now working perfectly, and we can now go to MIT App Inventor and start developing it. Now that we've done all our model part, let's try and create an app using MIT App Inventor. So once you've created your new project, go ahead and first drag a label to have our title and say diabetes prediction. And let's make the font size 120 so that it's the title, so it's going to be bigger. Then let's add a few text boxes. 4, 7, 8 text boxes. So the first one would have, go to behavior and click on the text, put pregnancies. See, since that was the first feature. The second feature we had was glucose, so let's put glucose. The third feature we have is blood pressure, so let's put blood pressure there. The fourth one is skin thickness. The fifth one is insulin. The sixth one is BMI. Seventh one is diabetes pedigree function. And then the last one is age. And so for all of these, let's go ahead and click numbers only, which means that it would only allow numbers to be fed into, or like to be fed into this text box, and it will be easier for us to manipulate the data later on when we're actually integrating the API. And let's also rename all of these to title, this one to, so it's easier for us to ensure what we're handling. This one can be called skin thickness. This one insulin. This one can be called BMI. This one pedigree. And the last one we can call it age. Now all of these would be, now this is all we need for our front end, because this is all the user has to input. So now let's go over to blocks. So the first thing we need to do is actually implement the logic for this, so that and put it into a form that the user would that the model would understand. So let's first go ahead and try to understand what to do. So let's first go oh yeah, sorry. Before we get into that, we need to make a button about predict. So this can be called predict, so that when the user clicks this predict function, the code will implement. So let's go ahead and go to blocks now. So first we need to, when predict is clicked, so sorry, we need to go to predict over here. And when predict dot clicked, which means that when it's triggered, when this is triggered, we need to, so since this code will be rather long, we're going to make it a procedure. So what a procedure is basically like a function in which we take in a few inputs, and then after that we take in a few inputs and then we get an output out of that. So let's first of all go ahead to, so let's go to the um, procedures function, and we to procedure do. So let's add a few inputs to this by going input x1, x2, x3, x4, x5, x6, x7, and x8. Now these are all features that would represent what we're doing. So we want to, when we call this procedure, we want to put that there. So call procedure, and then we want to put, so all of these represent parameters in which basically all of these represent parameters that will be the each of the features from the ML model. So pregnancies.txt will be the first one, then glucose.txt, then blood pressure.txt, then skin thickness.txt. Then after that we have skin, sorry, this should go in the trash. Then insulin.txt, sorry, it should be here. BMI.txt, diabetes pedigree.txt, and the last one age.txt. So after we have this procedure done, we want to then, so now what we need to do is actually put our, make sure that we have a way to communicate with our API. So go ahead and go to connectivity and drag a web component into this, into, just one second, drag a web component into here, into the screen, sorry. Yeah. So, and also we need, I forgot earlier, but we need another label over here that gives us the results. And then that would be whether we have the user has diabetes or not. So first, let's go on to the web component. So in the text, let's just rename it to connect to API, so that, again, so that we have some context of what we're trying to do. Then after that, we go to the we have to go back to our blocks code, and whenever we call the procedure, first we need to set the link, the endpoint of our link. So set connect API dot URL. So we need to make sure that this is where we go to our collab. We copy this URL into, we first go to control variables, sorry. We go to text, sorry, and then we click this. We drag one of the blank components there and we go predict. So this is our URL for the API. So we need to basically just copy that and paste it into the MIT App Inventor block. And what this does is creates a connection between the, it creates a connection between the API and the MIT App Inventor. Next, what we need to do is request the headers or the parameters that we're going to input into our input into our, like basically input into the model. So what we're going to do is set connect.api.request headers to a dictionary, make a dictionary of all these values. So we're going to put, so this would basically, the first one would basically be a what type of content we're going to input. So first of all, we need to have and ensure that we're saying that it's a JSON file. So first content type would be, type would go to JSON. So just go here and go to application/JSON. JSON. So sorry, JSON. What this means is that we're saying that we are inputting what data we're going to give is in in JSON. So now what we need to do is actually call an API or make a request to the API. So just go ahead and delete this first and go here and just take one out. So this is all we need. Then after that, we need to call um, so let's go to procedures. Sorry, no, connect to API. Call connect to API dot post text. This will create a post request that will let us put our thing into the put our like text into the MIT app and into the API basically. So let's go ahead and create um So let's go to text. In order to create a dictionary type thing like we had in Postman, we have to click join and add a lot of strings here. So let's add around 10 to 15 strings. What this is doing is basically we're going to have a few like, so we're going to have this in dictionary format. So this would be the opening bracket. Then we're going to have the next thing will be first is pregnancies. And then we're going to have the colon outside. And then we are going to have x1. So we're going to have the get x1. So this is going to do is basically say that pregnancies will be like this at the x value. Then we have um, a after that after pregnancies we have glucose. So let's do that. And before we actually do that, we need a comma here. So that'll ensure that it's kind of like a list type thing. So after we're finished with this, we have a comma. And we don't need it for the first one since that's the first element anyway. And over here, we're going to click X2. After glucose, we are going to put in blood pressure. And make sure this is one word because in the main model, we have this as one word. So after that, we have X3, we copy this and we replace this with, after blood pressure, we replace it with, the blood pressure, we replace the skin thickness. We change this to X4. Then after that, we replace skin thickness with insulin. And we copy this as X5. And we need more of these, so we need to just keep on adding a few. We need to add a few. Yeah, so let's just keep on doing this for all of them. So after insulin comes BMI. I believe it's all uppercase. Yep, it is all uppercase. Then we have X6 over here. After BMI, we have diabetes pedigree function. Diabetes pedigree function. And let's just verify, just copy paste it from here. Just to verify that it's okay, diabetes pedigree function. And we have diabetes pedigree function. So that's okay. Then also make sure that it's the same as the columns of the data frame so that we don't encounter any errors later on. And the last thing will be age. And we have to add one more over here. Let's just add one more. So let's add string and yeah. So after that we get x8 and then we put our last dictionary, our last closing bracket for the dictionary. So this is basically putting the data in a form that the model will understand. So after that, so this is basically done now. We have nothing. We have to just ensure that once we just have to make sure that when we have the data come back from the API, we need to display it in a form that the user would make sense of. So after that, when we just go to connect the API to got text, so when this basically means that when we get a text, we set the label of, oh, do we not have that? We have the results. We just need to rename that to results. My bad. So we go to results dot set results dot text to get response content over here, and that should be enough for us to really get into testing it now. So we are now done. So now I'll be showing you a demo of our app. Okay. Before we get into testing, I just want to correct one error. So for all of these, just blank out the text. So just make sure that all of these are empty and there's no text. That's all. So now let's get into testing. Also, another thing I'd like to correct is that before this is predict, just name it prediction if that's what you've put over here. And because we need to make sure that the route and the URL are the same for both. So we just need to fix that. That's all. So now we are connecting to the MIT App Inventor and it's now loading. So in a few seconds, you'll see the app screen. So just wait for around a few seconds and there you go. So as you can see, I'm entering the values of any random, I took any random row from the data set to check if it's working all right. And as you can see, I'm entering it one by one. The text boxes aren't very clear visibly, but that's okay since this is just for a project. It's not really a professional app. So as you can see, it says the person is not diabetic and this chat. So that was all for today's lecture. I hope you enjoyed and I'll see you next time. And next time will be a live webinar that I will be conducting on generative AI integrated with MIT App Inventor. Thank you.